Hey guys, today we're going to talk about the OSI network model versus the TCP network model. Now, you'll notice the OSI model is the one on the left side here, and the TCP network model is the one on the right side here. So each of those stacks, we're comparing them side by side. So yeah, TCP network model all in green, OSI network model light blue. So we have 7 layers for the OSI model and 4 layers for the TCP model. Now, one thing I'd like to point out before I really get into this, and I'm going to try to compare them in some kind of detail here. I have a bunch of things I prepared to say about these, but first thing I wanted to just point out here is that for the OSI model, layers 5, 6, and 7, it has been said that anything above layer 4 are lies and propaganda, and they do not exist. So essentially, yeah, some people would say that layers 5, 6, and 7 of the OSI model don't exist. Like and to basically to elaborate on that, personally, I think you could just combine them all into one layer. Yeah, as you see here, each of them, I drew some lines on here, and each of those layers 5, 6, and 7 all point over to the application layer on and I'm going to go through these one at a time, starting from the bottom in a little bit. I just want to compare them a little bit first, and then I'm going to go over what each layer is and what they do. So don't worry, we'll get to that. But yeah, so layers 5, 6, and 7 all correspond to layer 4, which is the top layer there, the application layer of the TCP model. So basically, all 3 of those get combined into one. So anyways, we'll come back to that. But yeah, so layers 5, yeah, they should really all, I personally think they should all be just combined, but I wouldn't change it. Leave it how it is. It's good to illustrate concepts and ideas. And the reason I would say don't change it is just because we already have the TCP model. I guess what I'm really trying to say is that I like the TCP model more because it's more practical. And yeah, anyways, moving along. Yeah, so a couple other things real quick. I guess I'll elaborate a little bit more now on those layers 5, 6, and 7. They a session could be established on top of an encrypted session. Even though you have SSL and TLS listed under layer 6, whereas the session layer is layer 5, technically you could establish an SSL connection and then establish a connection on top of that. So I feel like those could be flipped around a little bit. So I also don't necessarily agree on the ordering of those. And yeah, what else? Also HTTP. You'll see that's on layer 7. And you'll see like images like JPEG and GIF are on layer 6 because they're just image compression. Well, technically JPEG and GIF could be seen as being above HTTP because they'd be served within an HTTP packet. So that's another thing that just isn't real consistent with those. So that's what I kind of disagree with. That's just to compare them really quick. Now I'm going to talk a little bit about the let's compare and contrast them real quick, and then I'm going to go through each layer one at a time. So for the TCP/IP model, so it's more practical and it better matches how things actually work, and it is based on specific protocols. Now, it's also the foundation of the modern internet and the most widely used in practical networking. So it's less rigid and more flexible, and it's for real-world networking, and it has been developed by the United States DoD, or Department of Defense. Just a side note there. So that came along with the advent of the TCP/IP protocol suite and the internet itself. Now, the OSI model on the left here, it serves as a conceptual framework for understanding and teaching networking. So it's good for teaching the ideas and concepts, and I guess that's a good thing, even if it doesn't always map out to the real world and how things really work. Sometimes things are flip-flopped around. It's still good to teach concepts, but it's not really great for practical real-world use, right? So you should still learn it, and plus people are going to quiz you on it. If you're going to work as a network engineer or anything like that, or even like any other type of engineer, good chance someone might quiz you on this in an interview or something. So it's good to know these layers and what they are, and people refer to them in product documentation. So it's good to be aware of them, whether you agree with them or like them or not. Whichever one you prefer, you should be aware of both of these and be familiar with both. So anyways, more about the OSI model. It is a primary reference model for network architecture, and it's more useful for educational purposes than practical implementation. Now, it's more rigid and clearly defined, but doesn't match what's actually used. But still, it's rigid. It splits things into rigid sections or rigid layers that shouldn't necessarily be divided in real life use. But it's great to show the concepts and to help you think about the architecture of things at the same time. Now, the OSI model is developed by the ISO, the International Organization for Standards. Now, moving along here, let's just jump right into actually talking about what each layer is and compare them one at a time. So I'm going to go up starting from the bottom and with both of these in parallel and talk about what each layer is in order and kind of compare them here. So we're going to start out with layer 1, the physical layer. So on the OSI model, right? So layer 1, physical layer. This is the physical transmission of data, including cables, connectors, and signaling methods, also including radio networks and Wi-Fi and stuff like that. Now, moving up to layer 2 on the OSI network model, you have the data link layer. Now, this has to do with transmission between two nodes on the same network, protocols like Ethernet and Wi-Fi. So this includes things like the actual protocols for Ethernet and Wi-Fi, and it deals with actually connecting two things like, for example, a NIC to a switch or a switch to a router. It just from one point to the other, just the actual talking back and forth between two devices or however many devices, but the actual data link layer, that's what that is. So notice these two, I have lines connecting them over to the network access layer on the TCP network model. So basically, if you combine those two layers into one for the TCP network model, that's what you have. That's the network access layer. It's basically the exact same thing, except you take the layer 1 and layer 2 of the OSI model and combine them into one for the network access layer of the TCP model. Now, personally, I think this is one instance where, for practical use, you could combine them together because you really don't need to split them, but it actually does make some logical sense to separate them, and they are easily separable. So physical cables and stuff, it's easy to separate that from the Ethernet protocol. Like, that makes a lot of conceptual sense. And in this case, I actually think the OSI model is a little bit better. Now, let's jump up to layer 3, the network layer. This is responsible for routing data packets across networks using protocols like IP, ICMP, and ARP. This layer corresponds directly to the internet layer. You see I have the line there connecting them together. The internet layer on the TCP model, which handles addressing and routing of data packets across networks, host-to-host communication that is routed. That's basically what it is. It has protocols such as IP, ICMP, IGMP, ARP, and RARP. Now, notice these descriptions are worded slightly differently, but you could treat these layers as the exact same identical thing. They refer to the same thing. Basically, the main core concept here is that they use things like the IP protocol to connect one host to another host across multiple interconnected networks. So this is responsible for getting traffic from one host to another. So it includes addressing of these hosts and how you route things from one address to another. So that would involve like IP addresses and stuff. Whereas the lower levels below that, with Ethernet, would have like an Ethernet address to get between two physical devices, right? On the same network. This is for internetworking, right? Now, anyways, let's move along here to layer 4, the transport layer. So this provides reliable data transfer between endpoints using protocols like TCP and UDP. And notice the line here to the transport layer on the TCP network model. yeah, that's the exact same layer. So just like layer 3 is the same as the internet layer, layer 4, the transport layer, corresponds exactly to the transport layer of the TCP network model. They're the exact same thing. I worded it slightly different on each side, but it's the same thing. It includes TCP, UDP, and technically SCTP and DCCP. But normally the two main protocols you'd think of are TCP and UDP. And those are responsible for connecting two applications together. So one application will be connected to another application. Usually each application will be bound to a specific port. So each application uses a port, and those ports are they're going to be opened on specific hosts. But this layer does not handle host-to-host communication. This tells you which application on a specific host to connect to. So when you combine the information on this layer with the information on the internet layer, that allows you to hit a specific port on a specific host, right? So basically, to simplify it, layer 3 is IP addresses, and layer 4 is ports. IP addresses identifying a specific host on the network, and ports identifying a specific application on a specific host. Hopefully that makes sense. Now, layers 5, 6, and 7, we've already talked about these a little bit. So let's start with layer 5. This is the session layer. So this establishes, manages, and terminates connections between applications, for example, NetBIOS, RPC, SMB, and PPTP. So it basically is for establishing sessions. Now above that, you have the presentation layer. This is for data formatting, encryption, and compression, and ensuring that data is presented in a way that the machine can understand. So this includes protocols like SSL, TLS, JPEG, GIF, ASCII. Now notice that SSL and TLS would be a protocol, whereas JPEG, GIF, and ASCII are just encoding formats for images and text. And those actually get included in the presentation layer. You'd think that would be application specific, just data. TLS and SSL, I could see that being a network, a layer of the network model, but I feel like JPEG, GIF, and ASCII, even though they're encoding like technically their ways of encoding things, that's just data. That's encoded data that's just handled by the application. I would have put those at the very top personally. So even if you do split things into this many different layers, I don't necessarily agree with the ordering. I know it fits the description of compression and data formatting and all that. So that's how the images are compressed and how they're encoded. So technically they fit the description. And I know this is meant to be conceptual, so they fit the concept, but in real life, that's not how it works. And it just doesn't make that much sense. So it just doesn't fit how things really work in real life perfectly, which is fine because this is just conceptual, right? Now, layer 7, the application layer, this is applications and users such as email, web browsing, and file transfer. So this includes protocols like HTTP, FTP, and DNS. So all of those up on that layer. Now, as I pointed out before, you could have a JPEG on top of HTTP. So, layer 6 on top of layer 7. That doesn't quite make sense. But again, it's all conceptual on the OSI model. Now, layers 5, 6, and 7, you see that arrow pointing all of them to the application layer on the right side there. The application layer being layer 4 of the TCP network model. So this is basically, application protocols and data has protocols such as HTTP and HTTPS and FTP and SSH and DNS. And it also includes data, for example, images, HTML, etc. And as an example, HTML would run on top of HTTP, but both of those are just considered part of the application layer because it's just dealt with application logic within a program. It's not part of the TCP/IP stack. It's not part of network communication. It gets sent over the network, and it could also be sent locally. Anyways, it's the application layer. So essentially, you take layers 5, 6, and 7, combine them all together, and put them in the application layer. Because in real life, things are a lot more flexible, and the order you do things could be a little bit different. Things could be a little bit more interconnected, and they're more one process or or thing is way more dependent on another thing. They're not clearly delineated in real life. So they're interconnected much more tightly in real life, and they're a lot more flexible, and it's really all just handled by the application and by application logic anyways. Now, another thing to note that while the application layer will be typically handled by in practice, this is typically handled by a user level process, could be a root level process, but it's handled by user space, by an application in user space. Whereas the things beneath that, the transport layer, internet layer, and network access layer, are usually handled by the operating system. So the operating system will have network drivers and a TCP IP stack that will handle all three of those layers. They're all handled by the OS. And all that stuff all that functionality is provided by the OS, and the application will merely make use of the OS, while the application itself will handle everything on the application layer. But again, when you're talking about this conceptually, you're just talking about the concept of how all these network ideas fit together. So you're not necessarily talking about, an actual TCP stack implementation or how something really is implemented in code in the operating system and any of that stuff. No application logic, no operating systems, none of that for the OSI model on the left here. So again, just, keep in mind the left is all conceptual, and for what it's supposed to be, I think that's totally fine. If they just want to separate the ideas and treat it as a purely conceptual, abstract thing, that's totally fine. That's what it is. Just be aware that's what it is. It's not a real model, not the same way that the TCP network model is on the right side. So hopefully by this point you have a clear understanding of what these are. If you don't, I would suggest after looking this over a little bit, if this doesn't make sense to you still, you might want to take a step back and look at how the protocols themselves actually work, how they're one is encapsulated within the other, and just the ins and outs of how the protocols work. And once you learn more about how the networks work and how the protocols work and just more in general networking knowledge, then when you come back to these networking models, they should all make a whole lot more sense. So if you understand, for example, how an IP packet is encapsulated within an Ethernet packet, and how a TCP packet is encapsulated as data within an IP packet, and so on and so forth, and how how IP addressing and IP routing works, and all of that sort of stuff. Once you understand that stuff and have a good handle on that, all of this stuff should make a whole lot more sense if any of this is confusing. Now, any questions, comments, or anything else, leave a comment down below. If you felt like I did a bad job or didn't explain something well, let me know how I could have explained it better, or if anything was unclear, definitely leave a comment down below. And, might want to give me a thumbs up for this. And also, you're going to want to hit that subscribe button and the bell icon, because you don't want to miss out on our other great content. We're doing a lot more networking content. We do a lot of operating system content. We do a lot of Linux stuff, a lot of Unix stuff, a lot of Windows, Mac OS. We do a lot of hardware, software, programming, scripting, automation, a lot of DevOps stuff. We're doing like Kubernetes. We're doing like Raspberry Pis, electronics, robots, 3D printing, just a lot of tech stuff you won't want to miss out on. So make sure you hit that subscribe button. And before I forget, I did a separate video on each of these that I should have published just before publishing this one. So I did one video on the TCP network model and one on the OSI network model. To be honest, I think I covered both of those a little bit better in this video, but you might want to go check out those two videos that I also just published anyways. You might want to go take a look at those. But that's about it for today. So thanks for watching, and we'll see you guys on that next video.